Are you experiencing some of the many power quality issues in your facility? Do you need to bring in an expert to monitor and help understand what's happening in your electrical system? Monitoring power quality is no easy task. In this episode of The Power Grid, we will walk you through the steps to take when power monitoring. We'll go over the things to consider and the end result expectations. After all, prescription without diagnosis is considered malpractice. Let us show you how to monitor power quality. Hello and welcome to The Power Grid, the podcast that helps you build reliability in your electrical system and gives you confidence in your power. I'm Brian Brannigan with Power Protection Products, where we've been solving power quality problems for almost 30 years. Power quality monitoring is not an easy task. Working with power meters, applying them to the electrical system, and learning how to get results from the equipment takes time and training. Often one misstep in the setup and the configuration can turn the whole process into a waste of time and money. In this episode, we're going to talk about the important factors to consider when monitoring for power quality. We'll look at types of monitoring equipment, how to set it up, where to put it, and how to get the results from the monitoring process. Like I said, monitoring for power quality is no easy task. Often it's something we do with outdated equipment, old software, and lack of familiarization with the process and the equipment. Let me tell you a story. There once was this factory that needed to solve a power quality problem. They required metering for power quality. The local electrical contractor has done this a few times in the past, but that was years ago, and he wants to try to do it again. The old monitoring equipment was not as fast, was not as user-friendly, and he didn't even have a CD drive on his computer to run the required software to analyze the information. Things have changed a lot. It's important to use updated equipment, modern software, and most importantly, familiarity with the process. Prescription without a diagnosis is malpractice. Where you place the meters, how you install them, and how you pre-program the meters will all impact the results you'll get from this monitoring. Setup and configuration is very important when monitoring for power quality. The first step in solving a power quality monitoring problem is defining the problem itself. Using a good power quality analyzer in the right place will help you in this process. You're going to want up-to-date equipment, current software updates, correct CT sizing, and most importantly, you're going to want a trained user. The next step will be to determine your target. Are we looking at investigating problems? Are we looking at equipment sizing? Are we trying to observe a power anomaly? So it's very important to know what our target is because we're going to pre-program our meter to help us find that target. There are a lot of different power quality problems that you can find with power quality monitoring. Over voltages, under voltages, sags, swells, voltage transients, electrical noise, harmonics, grounding. All of these things will need to be considered when we're trying to figure out our target for power quality monitoring. Determining this target and what you're looking for is the most important first step in the monitoring process. This will impact the power quality meter placement, the setup, and the duration. So the right meter with the right information in the right location. There are a variety of types of power quality meters. It's very important that you know which type you're going to be using for what type of application. Speed is very important in power quality monitoring. So if you're looking for something like high-speed electrical transients, you're going to need to make sure that you have a meter that's capable of capturing the entire electrical transient. So you'd want to have a high-speed power quality meter to do that, and you're going to want to program it to capture these electrical transients. On the other hand, if you're not looking for electrical transients, you may not want to waste all that memory space in the meter by catching every little surge that comes in through the electrical equipment. So the right information is very important when we're trying to program the meter for what our target is. We don't want to overload the meter with information that's not going to be useful in our power quality analysis. The meter placement can also be very critical. Are we going to the switchboard, the panel board, the main service entrance, or even the outside utility? Are all factors that need to be considered when you're placing a power quality meter. Putting it in the right location is critical. If a customer wanted to add additional load to the facility engineer may need to determine if the existing electrical system could provide power for the new equipment. So you'd want to put that meter on the main switchgear. Sometimes there's multiple service entrances in a location. You'll need to determine if you want to put monitoring on all service entrances, or if you want to specify which service entrance has the power quality problem and put the meter on that. Sometimes with large facilities with multiple main services, you may need to go out to the utility feed and put the power quality meter at the utility feed, and this would require some coordination and approval from the utility company in order to make this happen. Meter setup is very important. We have to concern ourselves with the placement of CTs, the setup of the program, the equipment safety, the software updates in the meter, the exact meter placement, and also an external power source to power the meter. Also, the meter comes with a variety of parts and pieces that have to be set up correctly in order for it to work. There's a lot of voltage cables, voltage leads, CTs, jumper cables, alligator clips, power supplies. All of these things have to be working correctly in order for the meter to work. So it's very important to understand what's required for the meter setup and make sure that you have the cables that you're going to be needing for that sort of application. One of the more important areas of setting up a meter is the direction of the actual CT. CTs usually have an arrow on them. Sometimes they're hard to see, but there is an arrow on them. And you're going to want to face that arrow on the CT towards the supply side of the electrical system. Meters need to also be set up differently for delta and Y connections and any other sort of variety of electrical connection that you might have. You can understand that your meter is set up correctly by looking at the phasor diagram and understanding the importance of what's on that phasor diagram and how it's supposed to look when the meter's set up correctly. The next thing is the importance of data verification. Once the meter's set up and in place, it's very important that the data is being collected at the proper rate and in the proper form. Adjustments to this may be required based on the electrical system. Some of the issues are, is the meter working? Are the meter readings accurate? Does the meter data actually make sense? Sometimes you'll see a minus sign in front of a number that shouldn't be minus. Is the meter filling up its memory? Oftentimes we'll place a meter, get it up and running, and come back in a few hours and double check it and make sure that it's capturing data at the right amount of speed for capturing the data that we're looking for. A very important factor to consider is meter installation and removal. You need to have some sort of a systematic approach to the meter installation in order to do it safely and in compliance with electrical safety codes. Are you going to be installing this between 8 and 5, or is it on the weekends and the holidays? Who's qualified to actually install the power quality meter? Are we following the NFPA 70E procedures? Are safety meetings being held? Don't just hook it up and then later rip it out. It can lead to a lot of bad information. It's very important to check the information in the meter before you actually remove the meter from the system. The next step is to try and interpret the data from the power quality meter. Reports can come in many forms and many different levels of detail. Interpreting the data is a very important part of the process when monitoring for power quality. Reports come in a variety of shapes, sizes, and forms, different levels of detail. There are a few requirements that you're going to want to consider when you're interpreting the data. First of all, you're going to want to have updated software. You're also going to need a knowledgeable expert in using the software program, because this is something that you don't use very often, but you still need to know how to work it. You need to have the licenses of the software up to date. And typically you need to have an updated computer system in order to make this work. Presenting the results is the final step when doing a power quality monitoring job. Sometimes we do executive summaries. We'll report the findings in a presentation. We'll give various levels of detail in the data. And of course, at the end, make recommendations. That's where the prescription part comes in. Some surge suppressors today have the ability to date and timestamp and log power surges. Although this isn't a power quality monitor, it's a great way to see what's happening on your electrical system when it comes to transient voltage in the electrical environment. Having the ability to date and timestamp power surges is a huge bonus in the world of surge protection. So, in conclusion, monitoring for power quality can be a very challenging task. Consider all the factors that you're going to need, from setting up the meter correctly to using the correct installation and removal procedures, verifying the meter data collection, interpret the data, present the results, and then finally recommend a solution. Thank you for joining us today. If you're considering a power quality monitoring project for your facility, please give us a call to discuss the scope and purpose of the project. We would love to send you an estimate. The link is in the show notes.